Hi everyone, my name is Morgane Perron. I'm a postdoc researcher at the University of Tasmania in Australia. Thank you for the invitation to the OASIS workshop for a clean ocean. When we talk about ocean pollution, most of us can picture the image of a plastic bag floating at the surface of the ocean or a glass bottle down the seafloor. But these are just the visible aspects of ocean pollution. Today, we're going to talk about one invisible aspect of ocean pollution, which is heavy metals. Heavy metals highlighted in red here are natural elements present in the Earth's crust. Everything isn't all bad about heavy metals, as some of them, like iron, cobalt, and manganese, for example, are vital for marine ecosystems to grow healthy. On the contrary, other metals like mercury, lead, or nickel, for example, can be heavily toxic for marine life as well as for human if absorbed in high concentration. Heavy metals can enter the ocean by riverine discharge, sediment on the seafloor, and hydrothermal vents. They can also be deposited to the ocean surface in the form of aerosol particles and rainfall. Atmospheric sources, which are rich in potentially toxic metals, include natural fire emissions and volcanic eruptions, as well as human-induced emissions from industrial activity, traffic, household heating, pesticides used in agriculture, and shipping emissions. Following transport within air masses, heavy metals fall onto the ocean surface, and that's where they can cause harm to marine ecosystem. Due to their low concentration in the environment, heavy metal analysis in seawater and in atmospheric particles requires stringent laboratory processing and high-performance analytical instruments. For this reason, they cannot be directly measured using autonomous open ocean moorings or profiling floats, and they cannot be observed using remote sensing tools. Seagoing expeditions enable the simultaneous collection of seawater, aerosols, and rainwater in order to measure heavy metal pollution in the marine environment. However, shipboard campaigns are costly, and they only offer a restrained vision of the state of health of our ocean at a certain time and a certain location. The time series aerosol sampling station of Morgane on the island of Tasmania, Australia, is another great example of a scientific tool which is deployed to monitor heavy metal pollution in the atmosphere prior deposition to the ocean. While the station is set at a fixed location, it enables continuous monitoring of the heavy metal content of the atmosphere over a long period of time. The strategic location of Morgane Station at the Southern Ocean's gateway and downwind to one major air mass transport pathway of Australia offers a unique opportunity to capture the signal of episodic and unpredictable weather events like fire emission, which are otherwise very difficult to investigate. It also enables to witness a period of enhanced atmospheric pollution due to human activity, like shipping, for example. The Morgane station is located in a fairly remote place where pristine air masses often dominate the atmospheric loading. Monitoring heavy metal content in the atmosphere during background or unpolluted air condition can then help to better assess the magnitude and significance of higher atmospheric pollution periods. There are currently very few stations which are continuously measuring heavy metal pollution in the atmosphere or in the ocean, and I believe that time series stations are powerful tools to pinpoint prevailing sources of heavy metal contamination to the global ocean in order to implement new policies around those emissions. Thanks for your attention, and thanks to the IMAS biogeochemistry team down in Hobart.